Good day everyone. In this video we are asked to solve for x if 2 power x plus 8 power x is equal to 130. This looks like a very simple question, but then no quick method comes to mind looking at the question. So what we are going to do first of all is express 8 as 2 raised to power 3 then raised to power x. The same thing, just repeat this the way it is equal to 130. Okay, there's always a reason for doing this. It's so that we can express whatever is in this part of this equation as this part of the equation. So let me quickly remind us that if we have a raised to power m raised to power n, a raised to power m times n, or a raised to power m raised to power n, they are all equal, even if it is a raised to power n raised to power m. As long as it is multiplication, you can interchange them, one in the bracket or the other. Going forward, I'm going to rewrite 2 raised to power 3 raised to power x as 2 raised to power x raised to power 3. This is exactly what I mean. I'm going to write this as 2 raised to power x then raised to power 3. So I have 2 raised to power x here equal to 130. So that we can easily see 2 raised to power x in two places, which we can then use substitution of another variable, say p, to represent. Let p now be 2 raised to power x. That is, everywhere we see 2 raised to power x, we simply put the letter p. So our equation becomes p plus p raised to power 3 is equal to 130. Let me write this in descending power of p. This will be p raised to power 3 plus p is equal to 130. Now I can also bring this 130 to the left hand side, and when I do that, this becomes p raised to power 3 plus p minus 130 is equal to 0. I think it is much more easier to solve this now than it was in the beginning. So what we want to solve now is p cubed plus p minus 130. And to do that, we need to quickly remember our polynomial division. That's the best and the fastest way to do it, our polynomial division. But before we can do that, we need to get a factor of 130 that will make this whole polynomial, this whole expression on the left hand side, to be equal to what we have on the right hand side. We can go ahead and guess numbers, and we could be lucky, but the easiest way to do that is to look for factors of 130 instead. Factors of 130 normally will be 1 times 130, 1 and 130 could be 2 and 65. 2 and 65. Can 3 go? No. Can 4 go? No. 5 can go. 5 and 26. 5 and 26 will go. Now, 6, 7, 8, 9, 10. 10 can go. So 10 also is a factor. So 10 and 13. One of these should be able to uh, turn everything on this left hand side to 0. If any of this does not work, you can try their negative uh, variations as well, like -1 and all of that. So we can go ahead and try. If I put 1 here, it's not going to work. Because of this power 3, I need to look for something. Even 2 will not work. I need to look for something from around here. If I put 10, 10 here is 1000 already, which is far too higher than this. So let's try 5 or 26. But on a closer look, 5 is the most appropriate factor to use. So if I go ahead and substitute 5 into that raised to power 3 plus 5, then minus 130. Of course, this is 125 plus 5, then minus 130. This is already equal to 0. So it means that 5 here is a factor. Sometimes we could be lucky and we could get like 2 of these factors already. In most cases, we only get 1, and then we have to do polynomial division to get the other factors. So we have been lucky enough to get 1, and every other number beyond this line here is larger, so much that if I put them into here already, because of this power 3, is already far greater than 130, such that if I add p, it just makes it worse. So 5 is the only factor reasonable here. If we try the -5, -5 will be negative 125, then minus 5 minus 130. That's negative 260. So it means that -5 will not work. So let's just use the 5 and move forward. Like I said, sometimes you could be lucky, you could get more factors. But in this case, 5 is the only factor we can get. So to move forward, it now means that from this whole equation here, if we substitute 5, like I said, we will get 0. So 0 is a factor. So 5 is a factor. That is, p can be 5. That's what it means. Or p minus 5 is equal to 0. So it means that if I multiply p minus 5 times a certain expression, it should give me this. Now, what is that expression? That is when we will now have to do polynomial division. Divide this. That is, if you are trying to say 5 is a factor of 70, for instance, how do you get if you say 5 is a factor of 70, for instance, how do you get the other number? That is 5 times what will give you 70. So you need to do 70 divided by 5 to get the other number, which is 14. So if we say that p minus 5 is a factor of this expression here, of this equation, this function here, it means that we need to divide the entire function by p minus 5 to get that other factor. So what we need to do is to do p from this explanation here. So we say p raised to power 3 plus p minus 130 over p minus 5. This is exactly what we want to do. But before we can go ahead and do that, we need to make up for, these powers are arranged in descending order. This is p raised to power 3, p raised to power 1, and here there's an imaginary p raised to power 0. So we need to make up for p raised to power 2 that is missing. And to make up for that, we are going to put plus 0p squared, then plus p minus 130 over p minus 5. So this is what we want to do, but we're not going to do it in this horizontal form. We're going to use long division method like we were taught for polynomial division. If you have not been taught, just follow me closely and see how to do polynomial division. This is the trickiest part. Don't lose me at this point. So I'm going to do, so we are trying to do p cubed plus 0p squared plus p minus 130, so divided by p minus 5. Okay, this is very important for you to follow. So to divide, you are going to start each of the elements with this division. So this is p raised to power 3 divided by p. P raised to power 3 divided by p is simply p squared by law of indices. So I'm going to write it on top of this p squared. So that's p squared. Then I'll multiply that by p minus 5. So I have p cubed, that is p times p squared is p cubed, minus 5 times p squared is minus 5p squared. I'll subtract that. So this is minus, so p cubed minus p cubed is 0. Then minus is not necessarily minus. 0p squared minus minus 5p squared will give me plus 5p squared. So I'm going to bring down this plus p, so I have plus p here. This 0 is very useless here. I can remove it. I only put it because I was trying to explain, and that positive is also very useless there. So I don't need any of those. Then 5p squared, I'll repeat the process again. So 5p squared divided by p is simply 5p. So that's plus 5p. I'm going to write plus 5p here. So when you do that, then you repeat the multiplication process again. So 5p times p, this will give you 5p squared. Then 5p times minus 5 will give you minus 25p. Then you go ahead and subtract again. Okay. So this gives us minus 5p squared minus 5p squared are 0. Don't need to write that. Then p minus minus 25p is simply 26p. Then I'll bring down this minus 130 and then repeat the process. So I have 26p now divided by p, that's simply 26. So I'll write plus 26 here. Then multiply p times 26 is 26p. Then 26 times minus 5 is simply minus 130. If your division is correct, at the end of the day, because it is a factor, you must get 0, 0 here. That is, what you have on this line must exactly be the same as what you have on this line, so that when you subtract them, you have 0, 0. You don't need to write this 0, 0 because they are exactly the same. You can just leave it or put dot, dot. Okay. So at the end of the day, we got a new function which is quadratic. What this means is that at the end of the day, if we multiply p minus 5 by p squared plus 5p plus 26, this must give us the function we started with originally, which is this p cubed plus p minus 130 here. This. If we multiply, you can pause the video and give it a try to confirm that our division was correct. But if you already believe me and you are taking me for my words, let's just proceed. So it means that what we now have, instead of p cubed plus p minus 130, we now have p minus 5 into p squared plus 5p plus 26 is equals to 0. And by the way we've been solving quadratic, this simply means either this is equal to 0 or this is equal to 0. So let me write that. Either p minus 5 is equal to 0 or p squared plus 5p plus 26 is equal to 0. So from the first one, we can clearly see that our p is 5. That's a very clear solution. But let's check the second one to see if we can get another value for p. This looks like a factorizable quadratic equation, but is it really factorizable? Let's check. Mere looking at the term in the center here, you can see that according to quadratic formula, for you to be able to solve for p, it must satisfy this equation: p equals to minus b plus or minus b squared minus 4ac over 2a, where a, b, and c are simply the coefficients of p squared, p, and what you have here. This is a constant term. So the coefficient of p squared here is definitely 1. Coefficient of p here is 5, while the constant term here is 26. So if you go ahead and substitute that into this function, this formula here, you have minus 5 plus or minus the square root of b squared, which is 5 squared, minus 4 into a is 1, and then c is 26. I don't need to go further because I can see a problem here. B squared, 25 squared is 25. So 25 minus 4 times 26, 4 times 1 times 26 should be 104. Is 104. This is already a problem. It's a problem because you are going to get a negative. And by the time you get a negative, it means that under the square root sign here, you have a negative. And that's going to be the square root of a negative. I think that should be negative 79. Is it 79? 79. You can please check that. So if it is negative 79, that is already an imaginary solution. So we can abandon this whole quadratic function that we wasted our time to get because we are having an imaginary solution. So except, yeah, of course, except the question say find all possible solutions without limiting us to real value solutions. Except that we're going to ignore this. I can go forward and simplify this, but because it's already negative, we can abandon it if the question does not ask us to, find even the complex roots. But if you need to proceed further, from here you can go forward. Just substitute minus 79 here, and then you know what to do. Okay, going back to p equals to 5. Remember, p is not originally what they asked us to solve for. It was x, and we made that substitution here when we said let p be equal to 2 raised to power x. So now that we know that our p is 5, we can then say If p is 5, that means that 2 raised to power x, 2 raised to power x is 5. It's now easy to solve for x here, isn't it? So we can just take the logarithm of both sides to base 2. Take the logarithm to base 2 of both sides. So you have log to base 2 of 2 power x is equal to log to base 2 of 5. So that at the end of the day, when this x returns to the back of this guy, you have x log 2 base 2 is equal to log 5 base 2. And this log 2 base 2, according to the law of logarithm, is 1. So your final answer will be x is equal to log 5 base 2. It's as simple as that. Thank you so much for watching. If you have not subscribed to my channel yet, kindly first of all give this video a thumbs up, and of course subscribe to my channel. Thank you so much. See you next time.